The most recognizable aspect of the software is the workflow, and the workflow consists of symbolic representations of the different processing steps in any data mining project. And as you can see, we have these symbolic representations as nodes. If a project gets complex, you can spread it over multiple workflows. So you can see here I have multiple workflows, and you can link data across workflows, and of course you can link models also across workflows. This is enabled via a programming element called pointers. So these are symbolic references to the data. The data actually exists in the project, so we can point to it on multiple occasions. So for example, I can right click and put on workflow canvas, and as you can see I have multiple references to that data. So therefore we can link them, and of course model results across workflows. To also aid in terms of project admin, you can add comments, and so therefore you can have a legacy project that maybe you haven't looked at in a while, and you can come back to it and know exactly where it is. You can also ensure that somebody who has to take this up will also understand the elements of the project. So this is really good project admin. If we create a new project, a new empty project, very simply, file create project, you can name it, and as you can see it will present us with a blank canvas. To build our workflow we use the nodes, and these are spread across multiple palettes, 6 in fact, and we'll speak about these briefly for a moment. We can see the connect palette, and these are two-way connections. It's not import or export, it's both import and export. So we can read pretty much from anything and anywhere: text import, Excel, SAS, etc., etc. In terms of our profiling capabilities, as you can see, you can profile your data set in many different ways, for example, detecting outliers, etc., etc. There are some nodes across palettes that will be grayed out, and that will mean you don't have an appropriate license to access them. A note about licensing is that we provide one platform. Different licenses unlock different capabilities and functionality. So the third palette is the manipulate palette. So if you want to append, deduplicate, merge, transpose, filter your data, sort, all of those elements are contained in here. The modeling palette is quite vast, and in here we include our patented decision trees, which we'll show later, and our patented strategy trees, as well as other methods. For example, we have ensembling methods of boosting, bagging, random forests. We're on pretty much the edge of scorecard development, and as you can see here we do have scorecard nodes, multiple nodes for building scorecards. We include the traditional methods of both linear and of course logistic regression. As you can see also there are multiple nodes reflecting the same process. That might be slightly confusing, but notice this is Spark and this is Angoss. We'll speak a little more about that shortly. In terms of evaluating models, we have a series or a set of nodes here that will enable the generation of statistics and graphs to be able to fully assess the results of your model and of course evaluate its appropriateness. The action palette contains a set of nodes that will generate code for our native modeling nodes. So we can generate code automatically for SQL, SAS, Java or Python, and many others, as you can see. This also contains our optimization nodes, and as you can see my license for that isn't activated currently, so therefore they're grayed out. Now there's quite a lot of functionality, and as I said, there's duplicated functionality seemingly here. It's not duplicated, it's that Angoss is provided across multiple platforms. So as you can see we have a number of radio buttons here, so you can select the platform. That's a mechanism to filter out the nodes that are in the palette. So therefore, if I wanted to filter and see only Angoss nodes, I click for Angoss, and as you can see, it will filter and only retain and illustrate Angoss nodes across all of the palettes. And if you wanted to process it in another environment, you simply click that, and it will take you to those nodes. Now we also have a search facility, so if you're wondering how to locate a particular procedure or modeling method, type in the name, and as you can see here it's giving me 4 methods, so we can operate across multiple platforms. And just a note on that, we have integration capabilities with open source technologies including Python and R, and of course Spark. We also incorporate the ability to program in the language of SAS, so if those capabilities are needed, you can have one platform to program across all of those platforms without having to switch and have multiple elements or programs open. In terms of additional admin, there's one final thing I want to speak of, and that's in relation to the project. So you can see here I set my project folder from here. So when I create my project, it's going to create it in that folder, and that's simply a folder location on your machine somewhere. So if we locate this very briefly, you can see here C demo is where I'm going, and all of these folders correspond to project folders, and in that respect you can share them very easily. It's simply a matter of copying and pasting and providing that to a colleague or shifting it to some other location. It's open, and it uses the Windows file structure, so you can easily access and share these elements. And by the way, everything associated with a project that was conducted at the point of its creation will be available and visible if this folder is copied and shared. So therefore it can enable easy collaboration. Okay, so let's create a project and speak about the different platforms that we work across. So we've created the project. One thing I want to say here is that I generally create, prior to doing anything, a report workflow. And this simply uses what we refer to as a desktop document. Now, I can search for this very easily, and you can see it'll find it for me and highlight it. This is very important. The reason is because you can link anything to the project. So if it's a PDF document or a PowerPoint that you're using to describe the processes within the data mining that you're conducting at the moment, you can locate them all in the project. So therefore, you don't have to, again, have multiple elements open. Now, I've linked a presentation. It's an empty presentation. If I double click on this, it will now call that presentation. But notice the presentation is in my project folder. And if I open that up and modify it, you'll see that all of the elements that I modify, we'll just call this PPT1 and save it. And if we call it again, you'll see that that's retained my modification. So again, it's nothing complex. It's just the ability to locate everything that's associated with the project, regardless of what it is. Might be a PDF, might be a text file, a presentation, an Excel file, and you can put them all within the same project. So therefore, everything is consolidated. Okay, so in terms of operating across different platforms, we've spoken about Angoss just in general terms, but we provide the capabilities to program in other languages, for example, R. So if somebody has an R setup, we can certainly incorporate with that. Now, there's something to be borne in mind here, that open source technologies like R and Python are integrable with Angoss. So we don't provide the infrastructure. We assume that that already exists. We install Angoss, and we can communicate with that already installed infrastructure. So you can seamlessly connect, as you can see here, Angoss datasets to the R code node. Now that's the way we communicate with R. So if I click on R here, it opens up a palette, the wrong one actually, but here it is, the R code node. I can drag it out and connect it to Angoss datasets, and you can program to your heart's content in R if that's appropriate and something that's used. Now, you don't have to do all of the coding in one R code node. You can have multiple R code nodes, as you can see here, so you can split it up. In addition to that, if you're used to using an external program like RStudio to do your coding, you can also program from there, but have everything located in Angoss. And a very easy representation is I've created a project here, and if I open RStudio, you'll see that I have a custom R script here that I've called custom R script. That's on my session here, and I have an R code node that simply says the source is custom R script. And then when I go to R, you can see that this is the custom R script. So it's simply located here. I'm programming in RStudio, but everything is consolidated within the Angoss environment. Now, if you do use open source more broadly and incorporate Python, you can use these things simultaneously. So in the same way we have an R code node, we have a Python code node. And you can see here I've simply connected things and I'm outputting a data set. In relation to this, I'm programming here in R and here in Python, and as you can see, I've added comments to ensure that I know exactly what I'm doing. Maybe there's something wrong with my installation. However, that generally will work. Now, in relation to other connections that we have with other platforms, if people have an installation for producing graphs like Tableau or Click, we also provide connectivity with those. And the reason why I'm speaking about them in the same context as R and Python is, again, we don't provide the infrastructure. We assume you already have that installed or you have those licenses. You can use Angoss to communicate and connect with that. So we have a series of Tableau nodes here. So you can see, if I just locate one, we can find the others. Download Tableau template, create Tableau workbook, publish Tableau workbook, etc., etc. So if I click on a created workbook, again, this is going to call Tableau. And if you need, or if a client needs to work in Tableau or has that installed, they can seamlessly connect, as you can see here, Angoss datasets to the Create Tableau workbook. And then, of course, create their charts and graphs and distribute as they deem appropriate. So here's a simple representation. It's connected to the data set, and you can see this. I think I have a more complex one somewhere, if you bear with me a moment. This is looking at our text solution. So we also provide text analytics. And rather than discuss that in depth, I'm just going to show you that I've created stuff here with Tableau after modifying the output generated by our text capabilities. But the point is that you can reproduce this, the elements that we produce by default, and, of course, publish and distribute around the organization. So those connections exist. We also have that for Click. Even though it hasn't been specific here, I can again find the Create Tableau node, and you can see we also connect with Click. And again, this is the exact same in terms of its connections. We assume that you have the license, and when you double click here, it will call Click. So in terms of already having an infrastructure set up, we assume that to be the case for R, Python, Tableau, or Click. We can sit on top of it, call it, communicate with it, and you can ensure that everything is bookended, all your processing in the one environment. Now, we also have connections for the language of SAS. And what this means is that you can program in the language of SAS, or you can utilize this. What I'll do is I'll switch my license so I have those nodes available. So at the moment I'm illustrating Knowledge Enterprise. We can incorporate additional licensing to unlock the language of SAS capabilities along with the Knowledge Enterprise capabilities, but here I hadn't done that. So I'm going to launch Knowledge Studio and Knowledge Core, again the same platform, but just different licenses unlock different capabilities. So if I return, and let's reopen some of the things that I wanted to speak about. And this is the one. So I'm speaking about the language of SAS integration and how this differs, first of all, to our open source Tableau and Click integration, is that for those, Tableau, Click, Python, and R, we assume you have the infrastructure already installed. For the language of SAS, we provide the entirety of the infrastructure, so you're not relying on existing SAS licenses. And we use the term language of SAS specifically because we distinguish between the company and, of course, the products that they promote and sell. And now you can see here, if I click on LOS, all nodes or all palettes will filter nodes specifically for the language of SAS. So we have connections, capabilities, profiling elements, manipulations, modeling, evaluations, etc., etc. Now, what these do is front-end SAS code. So we front-ended the most popular procedures. And so you can see I have an example of that here. I have information from January, February, and March, and these are transactions. And so what I want to do is create a quarterly file. So I'll use an append node, and we can easily locate that here. And you can see we have 3 appends, so I'm going to go for the language of SAS append. Simply drag it onto the canvas and make the connections to those SAS files. And these are, of course, SAS files. Now, here you can see that it's all drag and drop and point and click connections. Shows you the files, the number of fields, the rows, and if the field names have changed from one month to the next, you can easily map them. So, for example, simply select it, and it will write the code for the procedure, including a rename, if that's appropriate to appropriately match the fields across the months. So we also have the aggregated, the appended file, and I'm using a summary tables node here to generate an aggregated representation, so based on customer ID, because of course customers may have had transactions across all of these months. I want summaries, and you can see these variables originally existed here. I dragged them to their appropriate locations and selected, in this instance, the summaries. So this is the grouping variable, and these are the summaries I'm generating. And again, we'll write the code for you. Now to proceed, I created the aggregated file. I'm filtering out some fields that have been added due to the programming, and then I'm importing demographics. So I want to enrich the aggregated, summarized transactional information with demographic details. So I've imported it, I've sorted it and deduplicated it based on customer ID, and then I'm enriching the transactional information. I'm doing a left merge here, merging matched detailed information for these records that I have gathered, and of course taking only matches based on customer ID as I specified here. So I output this file. This is my data mining view, and you can see again it's in SAS format. Now, at this point, there may be people who will consider that they want to access programming rather than a node which is wizard driven and point and click. So we also provide our generic code node. So in the same way that you can program in the language of SAS, or in open source technologies like Python and or via a generic or a code node, we also have a generic code node for programming the language of SAS. So you can see it's simply a matter of drag and drop, and again, seamless connectivity. So you can see this is a notepad interface where you can put your SAS code, and if you have existing macros and codes, they can be copied and pasted here. We also have a deeper debugging environment available via this run IDE to edit. So when I click on this, it's opening up our interface so that we can have color-coded programming, and of course we can debug the code to a greater extent. And this is our partner for the language of SAS environment, and it does have quite a considerable amount of functionality. So people who have been used to programming in the language of SAS in that tool, that's also available within Angoss. So as you can see, after clicking the Run ID to edit, it opens up this deeper debugging environment. And this is quite similar to a SAS environment, the exact same programming, no different. One element that we include here is that if I do something trivial, just to illustrate, I copy a piece of code and paste it. If I close this file and click OK, I'll save those code changes, and you'll notice that this has been relayed or cascaded back to my generic code node, so that can be incorporated again within the same environment. So we have those connections to those other platforms if there is usage for not only open source like Python and R, but also for the language of SAS. And finally, we do have Spark connectivity, so people, or if people are using a big data solution, we can connect and communicate with those file formats, and of course do some manipulations, and this will all be conducted in the cloud. Now, as you can see, these are all grayed out, so I have switched the license from Knowledge Enterprise to Knowledge Core, Knowledge Studio, so those aren't available currently. Okay, so that's really just an overview of what the platform provides. What I want to do is just step into a typical project and illustrate how you would proceed through that, from import, profiling, to building a model with our decision trees, to exporting, to strategizing, to monitoring over time, and then we'll go on to other elements that may be of relevance. So let's filter for Angoss, and I'm just going to import this Excel file that I'll use to demonstrate throughout. It's a small file, but it will be illustrative of processing that you can conduct, and of course the whole data mining project. So first of all, it's imported the data, and again notice that this is the data here in the project, and this is a symbolic reference. So if we open the data set, the first thing to do is of course to start profiling it, and we have a number of different profiling tabs displayed across the bottom here. If I go to the Data tab and click OK, you can see that it will show me a spreadsheet style display of the information, and we have some demographic details here: customer ID, age, education, marital status, etc. And we have some transactional information or financial variables, and of course we have a dependent variable. We can speak of this dependent variable and the process in many ways. This is binary, so we can speak of response or risk, etc., etc., or fraud or default. So we'll speak here of whether somebody's going to respond or not, whether something is going to happen. So I want to start profiling this data set. So I go to my overview report and generate some univariate statistics. And we can see we have quite a considerable number of statistics and an exhaustive list practically here available via different sections. Now, I've clicked on the options button there. That will change, or the options displayed will change depending on the profiling tab I've selected. Once you've had a look and are satisfied with this, or to complement the univariate statistics, we have univariate charts. To select the charts, simply use the drop-down or iterate through them using the CD-style display buttons. By default, categorical variables will be represented as pie charts and scale variables as histograms. So we can see here that you can modify that and you can play around with those options. They're quite straightforward. But you can represent data in any way you deem appropriate. Now, the default representations are simply that. So a very interesting element that we include is the ability to split the screen. And so let's have a look at that variable age. We can see it here. It's quite granular, and how it's represented is quite straightforward. In relation to histograms for continuous variables, we split the range up, 17 to 90, into 10 equal intervals. And those bins, 17 to 24, 24 to 36, etc., or 24 to 31, etc., are populated. So it's just a display format which you can modify. So I can manually enter values. It can change the display, and this is a means to get information very quickly. You also have automated methods. And notice as well that this isn't changing the data. I'm asking for quintiles here. The data stays as it is, but it's just a representation. So we have neat features and functionality there. If we have a look at the dependent variable, we can see its distribution. And in relation to this, we can see for our purposes, about 24% of people respond, 76% of people don't. The next thing to do can be quite arbitrary depending on the analyst. For example, what should we do next? The appropriate response is, of course, we try and identify variables that are potentially good predictors of this outcome. We have many methods to do that, and we provide a good mechanism to give you a push in the correct direction in terms of next steps, because somebody might do multiple other procedures. But here, using our segment viewer, is probably the fastest way to get some insight in relation to your data. So I've selected the dependent variable here. And what this will do is generate a series of charts. And we will see that there will be one chart for every variable as it's distributed in the data file in the whole. So here we have the variables, its whole data set distribution, double click for a larger representation, and of course its breakdown across each of the dependent variable categories. So we can use empirical methods simply viewing this to assess what variables might be potentially good predictors. So if they're contrasting in terms of their distributions, there's potential value. So here we can see the distribution of age is contrasted across the dependent variable categories. Those who generally respond are predominantly older. We can scroll down and just wait for other things to jump out. Again, we can see marital status. And those, again, who respond are generally married. And now we know that in addition to them being older. Now, that can be quite a considerable procedure if you're using empirical methods simply to shortcut it. And if you have quite a considerable number of variables, to shortcut that, we can use these two columns here. And we can list the variables in ascending or descending order of any of these statistics just to aid in shortcutting the process and drive the variables that are well contrasted or most contrasted up to the top. Now, this isn't panacea. It's certainly a good mechanism to give you insight to understand what variables are potentially good predictors. We also include cross tabulations. Those are quite standard. So, for example, select your column and row variable, and you can summarize a scale variable here. So we can have average something, and we can have multiple charts. access the table that lies behind that, etc., etc. We also include correlations, again, a standard element in any data analytics tool. In addition to these, you can modify this in place. So if I only want to see the relationship between one variable and all others, I can simply do that without having to export and modify in any other mechanism. We also include characteristic analysis. This is unique to Angoss, and what it does is extends the idea of a cross-tabulation to continuous variables. What that means is that, of course, we're looking at cross-tabulating the dependent variable with all others. If that variable is categorical, for example, like relationship or sex, that's quite straightforward because these are categorical. But what if the variable is continuous? What it does is applies histogram settings, and therefore the variable is pre-binned, and we use those bin settings to temporarily replace this variable to cross-tabulate it with the dependent. Because we have cross-tabulations, we can display one of three outcomes: the frequencies, the percentage of the row, or the percentage of the column. I'll accept the defaults here. And we can see that it will generate charts and tables illustrating the relationship. So we can see the cross-tabulation and the age categories that it's applied, as well as the representation. And here we're showing the column percentages. You can easily change it. And you can also see that it does that for every variable or every combination. Now, there's an edit binning button associated with each of these representations. So if you didn't like the binning, you can modify that for variables individually. So here I'll change it to quartiles, and we can see the impact that that will have. And it updates the chart as well, changes the variable. And so that's the profiling capabilities. Now we have other profiling capabilities, which I'll speak of very shortly. But in terms of dataset profiling tabs, one additional element that you have, which is very valuable, is the ability to export to Excel. So here I have the button, copy data to Excel, and this is a one-click export. Now it's not going to copy the charts and graphs. You can copy and paste those as a JPEG. But if you want the data that lies behind that, we can easily do that. So I'll just export it. I'll wait for it to tell me. Now, in the meantime, you can click on the other button here to the left of that export to Excel to access the binning structure, the tabular representation of these charts. And now once it's exported that, I'll open it. And in fact, what we can do, just to illustrate the desktop document, rather than have it outside of Angoss, we can incorporate it very, very simply. And I can put this onto my Reports tab, and I will create this, rename it. Go back here, and I'll remove that for the time being, and I'll put in another one. And link that segment viewer output that we have created so that we can view it. Of course, we could view it outside Angoss, but it's much easier in this respect to view it within Angoss. So I'm just going to call it SV and click OK. Now this is a method to link it. I'll double click it, and of course it opens it, and you can see it gives me the tabular representations, the whole data set distribution for the variable age when it's binned, and of course its distribution for each of the dependent variable categories, and it includes the statistics. So we have an easy mechanism to output large tables from seemingly complex representations with one click. And that, of course, is very valuable for things like characteristic analysis, segment viewer, but it's also available for the overview report. Okay, so let's get back to this project. Now, the next thing I'm going to do here, beyond the profiling capabilities which we spoke about, available across the bottom here, and by the way, you can split the screen if you want to have two views visible concurrently. What I'm going to speak about is the additional capabilities we have for variable identification. Now, quite simply, we use our profiling capabilities for the variable importance. We can output that. We also have the measures of predictive power, that's also in here. So these two. And you can also evaluate and get a list of variables in terms of their importance. I think that's, variable selection, which is here, and variable importance and measures of predictive power. You can investigate those at your leisure. What I want to speak about is creating new variables. So we have the ability to manipulate data, append, aggregate, deduplicate. And by the way, these nodes that I've accessed here via this mechanism of hovering clicking, dragging, and releasing is showing me all of the nodes across the palette, so it's just another way to access the same thing. So I'll go to variable transformations. This opens up the dataset editor, so I can add new fields, I can edit them, I can transform multiple fields, and I can share the expressions that I generate to do this. So I'm going to create a simple variable, I call it rel2. Now if I have SQL skills, I can type in a case expression. I can also use these folders to aid in terms of specifying and building the expression. Not only do we have variable names, but we have a series of SQL functions, we have help for those, and of course common operators. So simply double click to get into the expression. Now, if you don't have SQL skills, we have helpers that will automatically write the code for common transformations, including binning, logarithmic transformations, optimal binning. So I'll choose binning, I'll click next, find the field, and here you can see, give me a visual representation of the distribution across the categories of that variable. I want to create a binary field, so I'm going to highlight these two categories. Notice the distribution. Not only does it combine them, I can add a name, and also it shows me the cumulative distribution associated with the grouping that I've applied. Now, as a result of applying this grouping visually, it writes the code for me, as you can see. And if I click finish, the code is in the expression editor, and I can edit this if I desire. So if I want to use the code as a starting point, I know that if you're husband and wife, then you're married. Anything else, you're in other. But I don't know if this is an exhaustive list of all of the possibilities when I deploy it. So I would say then, change this. So case when relationship and husband and wife, then married, else other. So we can use the helper as a starting point to create the code. And also, another point, it will tell me whether the code is valid or not. So if you do intend to write that, and you can see there's a simple mistake here, we can get the program to validate it, and we can see now it's acceptable. So once we do that, I click OK. You can see the case expression for that transformation is available, and we can import and export. So if you do have a collaborative team, you can centralize all of the expressions to a location that everybody can access, and they can dip into and use that expression. So an expression, a complex one, only ever needs to be programmed or defined once. Now if I run, you can see it will output a new data set. Very simply, it includes the additional field that we created previously. And one moment, what I'll do is I'll just provide a bit of space here, and you'll see that it has the variable that we created, rel2. Now to make sure that it has done what we had wanted it to do, I'm going to use the variable relationship and the newly created rel2 in across tabulation and view the report, and we can see that husband and wife are now married and all others are in other, which is exactly what we wanted. Okay, to proceed on to modeling, prior to that, of course, we'd make some partitions. And I'm going to do this using the Angoss partition node. Very simply, I can add two partitions. I'm going to create one which will have 70% of the data, and I'm going to add a second which will have the remaining 30% to test the resulting model. You can use this for stratified partitioning, I should have mentioned, but here I'm just creating two randomly created samples, subsetting the data into partitions of 30% or 70% and 30%. So once these are created, we can proceed to building a model, and what we're going to build here is an Angoss decision tree. We could use other model types, and what we could do, of course, is create models using Python or the language of SAS and Angoss and compare them all in the same platform. So we could use the Angoss analyzer to simply compare those. And a simple illustration of that is here. I've created this data set. I've sent it to this modeling workflow. I've converted it into Angoss, connected an OR code node, and built a linear discriminant analysis model. I've also built a decision tree with Angoss, and I've also, with the prior to conversion file, built a logistic regression with the language of SAS. And the beauty of this is I can use the Angoss analyzer to assess all of those simultaneously. Okay, so back to this project. We have created our partition, so I'm going to connect a decision tree. And bear in mind that this is patented, so there's elements in here that you won't find in other tools. So here all I generally do is select the dependent variable. You can click next to set options, and I should say we have 4 different algorithms, and even though these don't say shade, C5 and CNRT, that's what they boil down to. So as I said, you can select next and specify options, but we recommend interactive tree building, so therefore I only ever need to select the dependent variable, and I'll choose the default algorithm, which amounts to C5, using information gain criteria to determine what variables are potentially good predictors. So if I open this, we can see that we're greeted with the root node. There's a considerable number of profiling tabs, and we can modify the representation. So we can modify the tree colors, simply click and change. You can modify the configuration, the orientation, what's visible in the tree nodes. I'll show the node number. You can see that's there now. How the tree would grow, and these are stopping criteria. So you can see these. And we also have directed help. So you click help here, it will open up the pages associated with the options that we have selected. So it's page and content specific. We can also determine what's generated and visible, as well as being able to dynamically modify and change the decision tree algorithm that's being applied. Now, in addition to that, you also have access to all of the attributes. This is quite granular, so you can modify the role, whether a variable is included, how to deal with and treat missing values, whether you have open left and open right values, so less than or equal to a particular value that represents a threshold in your data, like age. If there's only people in your data set that are 21, maybe you will have people who will be younger than that. So you can leave that bracket open, less than or equal to, or greater than or equal to. In terms of building the model, using interactive methods or automatic grow, and you can specify these options. We recommend using the interactive methods. Now, in terms of the profiling, I'll illustrate the split report, just to guide us along the way. And again, we can split the screen into multiple elements. I can right-click here and choose a fine split. What this does is assesses all of the variables, calculates the statistics and ranks the results. So that's why it's chosen relationship as the first splitter variable. And we can proceed in this manner, interactively growing the tree at each stage. And again, if I click on this node, the split report blanks, and I can choose fine split again, and it will populate, and I can see the order of the predictor importance, hence why it chose education. Now, in addition to this, it will retain the split report for previous nodes, and I can modify the splits. So I can choose a fine split to get an idea of what's the most important predictor and a ranked list, and I can modify the splits that it also generates. So here you can see that there's quite a considerable number of categories, and there seems to be too much of a granularity for those lower number of years of education, maybe up to about a high school graduation. So I want to put